Serverless computing has revolutionized the way we develop and deploy applications. AWS Lambda, a pioneer in this space, allows developers to run code without provisioning or managing servers. This flexibility comes with immense benefits, including scalability, cost efficiency, and reduced operational overhead. However, like any technology, Lambda has its limitations. Customizing the runtime environment can be restrictive. Managing dependencies, especially for complex applications, can become cumbersome. Isolating execution environments to prevent conflicts between functions is another challenge. These limitations can hinder the development and deployment of sophisticated, production-ready applications. Developers need a solution that retains the agility of serverless while providing greater control and flexibility. Fortunately, a powerful tool exists to address these challenges. Docker. By containerizing Lambda functions, we can overcome these limitations and unlock the full potential of serverless computing. Discover how Blackcoffer's team of highly skilled professionals leverage cutting-edge technologies to empower organizations and drive their success. From strategic planning to implementation, Blackcoffer is dedicated to delivering exceptional IT consulting services tailored to the unique needs of each client. Docker is the standard for packaging, distributing, and running applications in isolated environments called containers. A container encapsulates the application code, libraries, dependencies, and runtime environment. Dockerizing AWS Lambda functions involves packaging the function code and its dependencies within a Docker container. This container is then uploaded to a container registry and executed by AWS Lambda. This approach offers several advantages, including defining the exact runtime environment and simplifying dependency management. Before diving into implementation, it's essential to understand the key components involved in Dockerizing AWS Lambda functions. This is the core logic of your application, written in a language supported by Lambda, like Python, Node.js, or Java. A Docker file is a text file containing instructions to build the Docker image. It specifies the base image, dependencies, application code, and other configurations. A Docker image is a read-only template created from the Docker file. It contains the application code, libraries, dependencies, and runtime environment necessary to run the Lambda function. An Amazon ECR repository is a fully managed container registry provided by AWS. It stores Docker images and allows you to easily push and pull images. After building and pushing the Docker image, you need to update your Lambda function configuration to use the image from the ECR repository. These components work together seamlessly to enable the execution of your Lambda functions within Docker containers, providing enhanced flexibility and control. Section 4, Implementation, a step-by-step guide. Let's outline the steps to Dockerize an AWS Lambda function. First, create a Docker file in your project's root directory. Specify the base image, set the working directory, and install dependencies. Use Docker build to create the Docker image. Log in to AWS and navigate to Amazon ECR. Create a repository and push the Docker image. In AWS Lambda, select your function and go to Configuration. Provide the Docker image URI from ECR. Save the changes and test your Dockerized Lambda function. By following these steps, you can successfully Dockerize your AWS Lambda functions. Section 5. Navigating technical challenges. While Dockerizing Lambda functions offers significant advantages, it's essential to be aware of potential technical challenges and their solutions. First, ensure all dependencies are explicitly declared in your Docker file. Use package managers like npm or pip to install dependencies within the container. Next, leverage Docker's inherent isolation capabilities. Each Lambda function will run in its own container, preventing conflicts and ensuring consistent behavior. And finally, integrate your Dockerized Lambda functions with AWS CloudWatch for monitoring and logging. This integration allows you to track function performance, debug issues, and gain insights into your application's behavior. By proactively addressing these challenges, you can ensure a smooth transition to Dockerized Lambda functions and maximize the benefits of this approach. Section 6. Embracing the future. Dockerized Lambda functions. Dockerizing AWS. Lambda functions empowers developers to overcome key limitations of serverless computing and unlock its full potential. By embracing containerization, we gain enhanced runtime customization, simplified dependency management, and robust execution environment isolation. This approach allows us to build more sophisticated, scalable, and reliable serverless applications. As the serverless landscape continues to evolve, Docker will play an increasingly vital role in shaping the future of cloud-native development. Join us on this journey to uncover how Blackcoffer has earned its reputation as a trusted partner in the industry, providing unmatched solutions that elevate businesses to new heights. Don't miss out on the opportunity to gain invaluable insights and discover the possibilities that await with Blackcoffer. Like and share this video to spread the word about Blackcoffer's global expertise and industry-leading standards. Together, let's celebrate the achievements of this remarkable IT consulting firm and inspire others to reach for their highest potential.